All right, welcome back for another engaging and exciting experience in the world of probability. Today we are going to look at binomial probability, which is a special type of probability distribution. And yes, you have seen and heard of probability before. So we are going to quickly look at coin tossing again. So if we were to flip a coin, it could end up heads or not heads. Again, this is just notation. It's a silly, fancy way to say tails with a 50-50 shot. If I flipped another coin or the same coin a second time, if I'd gotten a heads, I could have gotten a heads or not a heads. If I'd not gotten a head, I could have gotten a head or not a head, etc. And so what I kind of want to look at is the fact that this outcome right here is really basically getting like heads all three times. This outcome right here is getting heads twice and not heads once. So I could put like heads twice and not heads. Put a little, that's not a that's that little tick mark there. This outcome is also getting heads twice and not heads once. So notice that these two things happen twice. This would be getting a heads and then not a heads. So that would look like there's a head, and here I didn't get heads, but that happened twice. And if I come down here and look, this again would be back to getting two heads and not getting a head. So that would be getting two heads. All right, I can make this work, I promise, and not getting a heads. This is not getting two heads and a head, so notice I'm switching colors to kind of represent that. It only has one heads, and then this happened twice. This again is the same thing I just did. I did not get heads twice, I did get heads once, so there's only one time I got heads. This time I did not get heads twice. And then this is a single outcome of just getting basically tails all three times in a row. So I switched colors again. And I just wanted to illustrate this, that this occurred once, this occurred once, and then the green outcomes happen three times, and the red outcomes happen three times. So we sort of have this strange 1 times h cubed plus 3 times h squared h prime plus 3 times h prime squared plus 1 times h prime cubed. And that was a very elaborate way to lead you down a path I want you to recognize in a minute if that didn't already ring a bell. What if I were rolling a six-sided die? And S could represent whatever side I'm interested in, so this could be like rolling a 5, and then this is not a 5, so this would be rolling all the other numbers. So again, I roll it once, I roll it again, I roll it a third time, and then notice that if A is getting a whatever number I'm interested in, so this is like you're getting your S, this is getting anything other than the side you're interested in. Notice again that if I do 3 rolls, or 3, yeah, I'm rolling the die, so 3 rolls, that this probability here, if I were to deal with this, sort of works out similar to what we just did with the heads and tails, except for getting rid of the S and the S prime. I'm putting in the actual probability calculations, and notice that this sort of looks very familiar and similar to something that we already did, and that was the binomial distribution. So we're going to use it to calculate binomial probabilities. There's a few pieces of information you need to look for in all of these problems. You have to be given a probability of success, and we will call that P, and that is the first thing you want to try to identify. That's usually given as a percent or a decimal, and you do want to identify that. If the probability of success is P, then the probability of failure is 1 minus P. So probability of failure we're calling Q, but Q would equal 1 minus P. So that's one thing you want to look for. And again, in binomial distribution, binomial literally means 2. And so in a binomial probability, when we're looking at it, we have 2 outcomes, and we consider them either a success or a failure, and that's it. So this is pretty important defining characteristic. The second thing is you have a fixed number of trials, and we will call those N, and you have to have that, it has to be given, and then you're interested in a certain number of successes. So if I had 10 trials and I was interested in 2 successes, notice then that the number of failures I would encounter would have to be 8. It would have to be the total number of trials minus the number of successes, because successes and failures have to add up to your total, just like P and Q together make 1. And we can use the binomial coefficient calculator and binomial that we used earlier to calculate these probabilities. We just have to, N is our number of trials, R is the number of successes I'm interested in, P is the probability of success, and Q is the probability of failure. So it's very similar to what we've already done. I will give you a very good example in a minute. This is our N choose R notation. That's very special. This is more of the calculator one, but these mean the same thing. Again, there's no division line in here, and this is similar to when we did our binomial expansion. So this is what I mean by trying to identify information as you go. So in a store, out of all the people who came, there are 30% who bought a shirt. That 0.30 is my P. I'm labeling it. If 4 people came in the store, all right, look at that. There is my fixed number of people coming in the store. Find the probability of 1 of them buying a shirt. That means my R is 1. So I'm interested in what is the probability of having 1 success out of 4. And so if I did this the old-fashioned way, I'd go 4, choose 1. And the probability of success is 0.30 to the first power. And if the probability of someone buying a shirt is 30%, the chance they don't buy a shirt is 70%. That's my Q. Those have to add up to 1. This has to be a 3, because if 1 of the 4 people bought a shirt, 3 of the people did not buy a shirt. And so now I would open up my calculator, which I should have already done, and I apologize for this extra delay, but it's a great opportunity just to say it's been a fantastic year, and it's been super fun teaching you all of this great math, and I hope that I see many of you again down the road. And if you're a senior, I wish you the best of luck in all of your future endeavors, and I am going to figure out where my calculator is. Found it. Notice I've been doing linear regression, so I'm going to get rid of that. If I want to do this calculation in my calculator, I have to do 4, and we hit that math button and go back over to probability, and there is our NCR button right there. I pull that up. It's 4, choose 1, and that will automatically calculate how many different ways this could happen. I'm going to multiply that by 0.3. I don't need to type in that exponent because it's just there as a 1. And I'm going to multiply that by 0.7 raised to the 3rd power. There it is. And if I hit enter, then our answer is 0.4116. So the probability of 1 person out of 4 buying a shirt is 41.16%. So you're going to pause right now and you're going to try the same thing. So pause the video and give it a go. All right. Hopefully you had a chance to jot down some stuff and then also put it in your calculator. Just very quickly, this is your probability of success. This would be R because I'm interested in 10 customers. And if I want to make sure Sam's right, I'm actually interested in the probability that exactly 7 of the 10 were to choose this. So if I did that, you would have had 10 choose 7. 7 people at the 70% means 3 people are at the 30%, and you should have gotten 0.2668 or 26.7%. All right. I'm going to move on now. I'm going to show you a little extra trick with your calculator, and then you're going to have one more example after this. So this isn't going to be too extensive. I probably will have to go to a second video though. All right, so you've got a rifle shooter. His name's Hugh. He fires a shot. Historically, apparently, he hits the target 80% of the time, so I'm going to circle that because I just have my p-value. My probability of success is 80%, and notice that a success is considered him hitting the target. If Hugh fires 4 shots at the target, so now I know he's shooting 4 times. Determine the probability that he has 2 hits and 2 misses in any order. So in any order means doesn't matter. It could have been 2 hits first, 2 misses. Could have been a hit, a miss, a hit, and a miss. So what that tells me is I'm just interested in that fact that he got 2 hits. So this is what I'm interested in being a success. So I want him to have 2 successes anywhere in those 4 shots. So this is our good old probability of x equals 4. And if I did it the old school way, I'd say 4, choose 2. And I would have to say he's 80% of the time he's going to get it twice because I want 2 successes, which means he misses 20% of the time, and that's also a 2. But there's another place you can go in your calculator, so pay attention, kids. If you want to do a binomial distribution calculation with this without doing the NCR, first off, you can do this. Go for it, no problem. But there's also this little distribution button right above vars. So if you hit second distribution, and it is way down there, so I'm going to actually scroll up from the bottom, and there it is, binomPDF and binomCDF. Very big and important difference. Binom, I don't know how I got to draw. I'm going to go back to distribution. I'm going to go back to it. Binom, that's how it happened. binomPDF is when you are exactly equal to in your calculation. So I have an exactly equal to 2, so I need to do a PDF. So I select PDF. It wants the trials. I think he was taking 4 shots. He that's your probability of success. So he's an 80% successful shooter, and I want him to have 2 successes. This will automatically calculate everything that you just did with the NCR. And so the answer would be 0.1536. So let's talk about that, and that is when I have an equal sign here, I'm going to use binomPDF. Very important, PDF, probability density function, that is for exactly equal to. Now I'm asking you, what is the probability that he has at least 2 hits? That's greater than or equal to 2. So you have a couple ways to do this. One, you could say, oh, well, greater than or equal to 2, I could do, that means he could have 2 hits, or he could have 3 hits, or he could have 4 hits. And you could do this calculation 3 separate times, doing this PDF 3 different ways and add those up. Or we can look at the fact that our calculator will do a calculation for us, but it only does less than or equal to, so it won't do this. So what I have to recognize whenever I see a greater than or a greater than or equal to is that here are my possible outcomes. I can either have no hits, 1 hit, 2 successes, 3 successes, or 4 successes. And right now this is asking me for these right here. Greater than or equal to. Well, my calculator does less than or equal to, which means my calculator could calculate this stuff right here. So if my calculator can calculate that, notice that it can calculate the probability that x is less than or equal to 1, but I want greater than or equal to 2. So the nice thing is that this little fancy red cloud and this little blue, whatever shape this is, those 2 events together have to add up to 1 because that's all the possible situations. So if you have a greater than or equal to, you need to turn it into a 1 minus the probability that x is less than or equal to. And depending on what this is and what this symbol is here dictates where you'll start. But I have to start at 1 and below because 2 is included in this. So this is what I have to find out. And not surprisingly, that means I really do have to do 1 minus. But when you have a less than or equal to, that's when you can do your binomCDF. CDF for cumulative. So we're accumulating everything from 1 down. It only does it for less than or equal to. So if I go back to my calculator, I can go 1 minus, and I'm going to pull up vars, and I'm going to again go to binom, but now I'm going to choose CDF because I'm less than or equal to. I believe I still have 4, right? And he's still 0.80, but I want to be less than or equal to 1. And I paste that in there, and I calculate it, and I get 97.28. So it's a 97% chance that he would hit at least twice, which makes sense because he's pretty good. All right, you're gonna, I already did that. You are gonna try this, pause it, and check your answers. All right, pause. All right, here are your answers. And in a minute, I will show you on the next video how you could have done that differently in your calculator.